All right, welcome. If you're a manager who's ever felt like you and your engineering team are speaking two different languages, or if you've ever wondered why a feature that seems so simple on the surface is taking weeks to build, then this explainer is for you. We're going to break down the mental models your team uses every day so you can lead them way more effectively. So let's kick things off with the big question. What is computational problem solving? It's a term that gets thrown around a lot, but understanding what it really means is key to unlocking how your technical team thinks and works. And here's the first surprise. It's not really about computers at all. At its heart, it's a specific way of thinking. It's about taking any problem, no matter how complex, defining a clear input, and then designing a precise, repeatable sequence of steps that will always give you the right output. That process, that's what your team is paid to figure out. Now, to build that process, engineers really lean on three core pillars. And the first one, maybe the most important one for any manager to get their head around, is something called abstraction. It's the secret weapon we use to manage overwhelming complexity. You know what? To really see how this works, and more importantly, where it can go wrong, let's just do a quick little thought experiment. You can just picture this in your head. That's totally fine. Okay, step one, nice and easy. I want you to draw a circle. Got it? All right, now, right underneath that circle, draw a square. And for the final step, draw a triangle right below the square. So you should have a stack, a circle on top, then a square, then a triangle at the bottom. So how's it look? Does your drawing look exactly like what the person next to you would have drawn? Probably not. Does it look like the one I had in my head? I was picturing this little house shape. See, when I said draw a circle, that's an abstraction. I didn't tell you how big or what color or exactly how far below it should be. I left all this room for you to interpret my meaning. And that right there perfectly captures the challenge of managing technical projects. For us humans, abstractions were great, but for a computer, they are dangerously ambiguous. A computer needs every single detail spelled out. Any tiny bit of missing information can cause bugs, errors, or a feature that just completely misses the mark. A huge part of your team's job is translating your abstract business goals into those painfully explicit instructions. Okay, so that leads us directly to our second pillar. Once the team has nailed down exactly what needs to be done, they have to decide how to do it. And that, my friends, is the world of algorithms. An algorithm is really just a recipe. It's a specific step-by-step set of instructions for getting something done. But here's the thing that every manager needs to burn into their brain. Not all recipes are created equal. Some are just ridiculously more efficient than others. Let me make this super clear with a classic example. Imagine I hand you a giant old-school phone book and I tell you to find Mike Smith. How would you do it? Well, you've really got two options. Method one is what we'd call brute force. You start at page one and you just read every single name until you find him. It'll work, eventually, but it's gonna be slow. Method two is the smart way we all do it instinctively. We call it divide and conquer. You just rip the book open to the middle, you see you're in the M's, and poof, you've just eliminated half the book in one move. You just keep doing that, cutting the problem in half over and over again. Now this is where it gets crazy. Just look at these numbers. If your phone book has 1,000 pages, the brute force way takes, well, 1,000 steps. The smart divide and conquer way, it takes about 10. Now let's scale that to a real software problem, like searching a database with 4 billion records. The brute force method would take 4 billion steps. The smart way takes, wait for it, just 32. Yeah, let that sink in for a second. 32 steps. This isn't just some minor optimization we're talking about. This is the difference between an app that feels instant and one that's completely unusable. It's the difference between a feature being possible or literally impossible. This choice directly impacts your server costs, your customers' happiness, and whether your product can scale up. And this whole idea of efficiency brings us perfectly to our third and final pillar, data structures. Because how fast your algorithm can run almost always depends on how you've organized your information in the first place. And that is always, always a game of trade-offs. So, a data structure is just the container your team chooses to store information in. But that choice, made early on, creates massive constraints down the road. It basically decides ahead of time which things are going to be super fast and which things are going to be painfully slow. Let's look at two classic ways to do it. An array is like having a row of numbered seats at a movie theater. If you need to find seat number 103,
bam, you can go right to it. It is lightning fast for finding things. But what if you need to add a new person right in the middle? Oh, it's a disaster. You have to make everyone get up and shuffle down a seat. It's awful. Then you have a linked list, which is more like a conga line. Adding a new person is easy. They just jump in wherever. But if you need to find the 103rd person in that line, you have to start at the very beginning and tap every single person on the shoulder until you find them. So it's slow to find, but fast to add.
And this quote just nails one of the most fundamental tensions in all of software engineering. There's almost never one best way to store data. There's only the best way for the specific problem you're trying to solve. Do you need to find data quickly or add new data quickly? You usually can't be great at both. Are you optimizing for pure speed or trying to save memory? It is always a trade-off.
So let's pull all of this together. Why does this matter? What does this actually mean for you sitting in the manager's seat? How can you use this?
Well, first, it helps you appreciate the hidden complexity. When your team is stuck debating what seems like a tiny detail, they're probably wrestling with these deep questions about abstraction and trade-offs. Second, it lets you ask way better questions. Instead of just, is it done yet? You can start asking things like, what happens to the performance of this approach when we have 1 million users? Or are we optimizing for fast reads or fast writes with this data structure? And finally, it lets you be a real partner in guiding those trade-off decisions, the very decisions that dictate your budget, your timeline, and what the user ultimately experiences. So I'm going to leave you with a question to chew on. Think about a project your team is deep in right now. Can you identify the core trade-off they're debating? Is it a classic fight between speed and memory? Maybe it's flexibility versus simplicity? Finding and understanding that core tension, well, that's your first real step toward becoming a truly great technical leader.